In chapter 4.1, we start by looking at percents. The word percent, if you kind of break it apart, means per cent or per 100. And if you think of it as kind of like a fraction, 1% would represent 1/100th of a quantity. One of the first skill sets that we want to develop in this section is to convert between different forms. In particular, fractions, decimals, and percentages are all things that we're going to ultimately use. And so we want to understand how to convert back and forth between those three forms. To convert a percent to a fraction, what we do is we write the fraction with the percent in the numerator and put it on top of 100 and then simplify if need be. For example, let's convert 80%, 37.5%, and 6% to decimal form and also to fraction form. From a percent to a decimal is the easiest one because all you're going to do is slide the decimal spot 2 places to the left, which would correspond to the 100th position in a decimal. So if I have like 80%, imagine the decimal spot as being behind the last digit here. Move it 2 places to the left, and that's how we go from percent to a decimal. So 80% is 0.80. If we had 37.5%, again, you slide the decimal spot 2 places to the left, move it there, and then throw away the percent sign. We would see that 37.5% is equivalent to the decimal 0.375. On occasion, if we have something like 6%, we need to add an extra 0 to keep moving the decimal spot. To go 2 places to the left, 1 place would move it around the 6. We add a 0. That allows us to move it 2 places, and we would end up with 0.06. So 6% is equivalent to 0.06 as a decimal. Now let's convert these to fractions. Again, we said that percent means part per 100. So what you do is you take the number that you see, you stick it on top of 100, and you throw away the percent sign. So 80% is equivalent to the fraction 80 over 100, which of course we would want to go ahead and reduce. 80 on top of 100, notice that they both have a ending 0. So you can chop that off, which is equivalent to dividing both top and bottom by 10. And then 8 over 10, both of those are divisible by 2 to get the reduced fraction of 4/5. Of course, if you're reducing fractions, as we saw before, it's usually easiest to reduce with the GCD. The GCD of 80 and 100 is 20. 20 goes into 80 4 times, goes into 100 5 times, and that would give us our simplest fraction. Same thing for 37.5%. We want to write this as a fraction. So we go ahead and we throw away the percent sign. We put that number on top of 100, and we get 37.5 over 100. Now, this expression here, to some of us, might seem a little bit odd because, yes, we have a fraction, but notice that there's a decimal within that fraction. We can correct this by sliding the decimal spot in the numerator, how many places we need to make a whole number, which would be 1 place to the right. If we do that in the numerator, then we would also have to do that in the denominator, slide the decimal spot 1 place to the right. And what that would tell us is that 37.5 over 100 would be equivalent to 375 over 1,000. And then once we kind of do it like that, we can just simply kind of go ahead and reduce it from here. For instance, we know that both of these would be divisible by 25. So just kind of looking at it, I notice 25 right off the bat would work. 25 goes into 1,000 40 times. And 25 goes into 375. That would be 15 times. We can reduce it a little bit more because now both of these are divisible by 5. 5 goes into 15 3 times, and 5 goes into 40 8 times. So we would get the reduced fraction 3/8. So 37.5% is equivalent to the reduced fraction 3/8. And I would also see now that the GCF of these two would have been 125. So if you wanted to do this directly, the greatest common divisor of these two is 125. 125 goes into 375 3 times, and the 125 would have divided into 1,000 8 times. The last one we have, again, if you want to convert from a percent to a fraction, you simply throw away the percent sign, and you put that number on top of 100. We reduce this, and it would reduce to 3 over 50. So 6% is equivalent to the fraction 3 over 50. We can also convert 2% to go from a decimal to a percent. We're just going to slide the decimal place to the right 2 places and add the percent sign onto it. To change from a fraction to a percent, we will first change the fraction to a decimal by dividing, and then change the decimal to a percent. Okay. For example, if we wanted to convert each one of these to a percent, for the first two, it's pretty straightforward because they're decimals. You just move the decimal spot over 1, 2 places to the right, and add on the percent sign. So 0.472 would be equivalent to 47.2%. 1.03, again, decimal to a percent, you're sliding it 2 places to the right. That's going to give us 103, and add the percent sign. For fraction to decimal, just to be from fraction to percent, the easiest way is to go to a decimal first. This is something you can use your calculator for because we are allowed to do that in the class. If you punch in the fraction 7/8, which is 7 divided by 8, this would give us the decimal 0.875. From there, we would just slide it 2 places to the right, and that would produce 87.5. And don't forget, add the percent sign at the back. So 7/8 is equivalent to 87.5%. If we do 5 divided by 6 in the calculator, you would get 0.83333 repeating. If I move the decimal spot 2 places to the right, notice that we're going to get an 83.3, and then that 3 gets repeated. The easiest way to represent that is with the bar over the top. So 5/6 is equivalent to the percentage 83.3 bar percent. A lot of times we need to use percent values within our mathematical calculations, but it's important that whenever you try to use a problem that involves percentages, we must always change them to a decimal first. For example, if we wanted to ask the question, what is 50% of 10? In order to do a problem of this type, we would first change the percentage to a decimal. That would be sliding it 2 places to the left. So obviously that would give us 0.50 or 0.50. Of means multiply, and then we would take 0.5 times 10. If we multiply that, that is or would be equal to 5. According to Fast Staff Travel Nursing, about 9.1% of all registered nurses in the U.S. are men. The average hospital had 347 registered nurses. How many of them would be likely to be male? So this is one of our problem-solving strategies. We know, and I'm going to write down the pseudo equation. It's 9.1% of nurses are men. So if we want to figure out how many at this hospital would be men, it should be the 9.1% of 347. To do that percent of, again, it's very important. We need to change that percentage to a decimal. We're going to take the decimal spot and slide it 2 places to the left. 1 place will go around the 9. We add a 0, and that'll bring it to there. So 9.1% should be the same thing as 0.091. And again, of means multiply. In our calculator, if you do 0.091 times 347, that will give us around 31.577. And again, we can't have 0.577 of a person, just round it to the nearest whole number. So that'd be about 32 male nurses at this hospital. Let's find a percent from a discount. In this problem, they talk about some Macy's coupons. I did not write these, by the way. These are the publisher's notes. But it says, my wife is an absolute wizard with Macy's coupons. As a high-volume shopper, there are quite a few coupons in the mail. One recent mall outing, she found a lovely red dress that sells for $79. There's 2 coupons for which they can try to apply to this purchase. One that's going to offer $15 off the purchase of 50 or more, and then the other one would just offer 20% off any one item. The question is, which is the better choice, and ultimately, how much will we pay for the dress? Okay. First of all, with these 2 coupons, notice that this one applies to any item. So automatically, we know that we could apply one coupon that would take 20% off the purchase price of the dress. The second one notices that it's $15 off, but with the stipulation that the purchase has to be $50 or more. Because this dress is $79, it exceeds that threshold of $50, so this would be an eligible coupon for this particular item. When they say which one is the better choice, you can look at it one of 2 ways. You can either consider which one would give us the overall lowest price, or you could focus by asking this equivalent question of which one would give us the largest discount or amount off. Let's look at the $15 off first. Okay. If I were to take $15 off of this purchase, and I know the book does it slightly differently, but if I have a $79 dress and we take $15 off of it, then that means our purchase price would be what? $64. So using the $15 off of 50, the purchase price would be $64. If we compute how much the discount would be if we take 20% off, 20% of 79, we would first work that out. That would be 0.20 of, again, means multiply, 79. We can punch that into our calculator. 0.20 times 79 would give us an amount of discount of $15.80. So that would be the amount of discount. If we then wanted to see what the purchase price would be, it'd be 79 minus 15.80 for a total purchase price of $63.20. So obviously the 20% off coupon, that's the one that's going to give us the biggest discount. So that's the one that we're going to use. And then the purchase price for this would be the $63.20. Another way that we could have worked out the percent discount. So unless you're actually curious as to how much you're getting off, most people just want to know how much am I going to end up paying. And notice that if the amount of discount is 20% of 79, then the amount that we would actually end up paying is we end up paying 80% of the price. So if you were to do 0.80 times 79, that would give us directly the $63.20, which would be the amount we have to pay. And then if you were to do this, it would save you that extra step of having to take the 0.20 times 79 and then subtracting it from 79, you would come out with the final price at the very end. There's a follow-up part to this. It says, let's suppose that the sales tax at this particular place of purchase is 6.5%. What would be the total cost of the dress, including the sales tax? So from our previous answer, we already know that we're going to be paying 63.20 would be the price of this dress. The final amount and the total amount is going to be the amount of the dress. It's going to be the price, plus we have to add the sales tax. And sales tax, excuse me, I'm not sure why this isn't writing properly. To compute the sales tax, it's a percent of problem. If the rate is 6.5%, we know that that's going to be 0.065 as a decimal. of the sales price, that means times the price of 63.20. If we work that out, 0.065 times 63.20 should give us 4.11, which is the amount of tax. So the total price of this dress is going to be the price of the dress, which is the $63.20, plus the sales tax, which is going to be $4.11, which would bring the overall total price of the dress to $67.31. Let's take a look at another example. It says a medium-sized company reported that it had to cut its workforce back by 70% of what it was last year. If it has 63 workers now, how many did it have a year ago? So they cut it back to 70% of what it was last year. It has 63 now. How many workers did it have a year ago? In order to answer a question like this, let's first write out a pseudo equation that relates all of the important variables. So it's 70% of a year ago is the workers now. That's kind of what they're telling us in the wording of it. The 70%, we know what that is. That's going to be what, 0.70. We know of means to multiply. And the standard algebra trick, they're asking us how many workers did it have a year ago? Well, if we don't know that number, we can represent with the variable. Let's call it the variable x. So 0.70 times x is the number of workers now. And we know that that is going to be the 63. So when we translate the pseudo equation into an algebraic equation, this is the equation we get. We get 0.7 times x, which in algebra we know we write as 0.7x equals 63. From our second unit, we know how to solve an equation of this type. To get the x by itself, we would need to divide both sides by that 0.70. And we would get x equals 63 divided by 0.7 would be 90. So this company would have had 90 workers 1 year ago. Again, these are those problem-solving steps that we talked about. It might sound a little bit silly, but writing that pseudo equation, instead of having to do the big jump from the worded problem right to the equation, try to add in this extra step where you describe in words what are the key relationships between the knowns and the unknowns of your problem, and that step oftentimes will help you to translate into the equation. Here's another example. They say a real estate agent receives a 7% commission on all home sales. How expensive was a home if she received a commission of $5,775? So the way that sales typically works is people receive a percentage of the price of their sales. So the commission rate times the sales price is the amount of commission. We know the commission rate, that's 7%, which we can write as 0.07. The sales price is the thing that we don't know. So let's call that X. And we do know the amount of commission was the $5,775. So 0.07 times X equals 5,775. In order to get the x by itself, we would need to divide both sides by that 0.07. And this would tell us that x is equal to about $82,775. $500. So the sales price of that home, the purchase was $82,500. The next application of percentage we're going to look at in this section is that for percent increase or decrease. Okay. In order to find the percent increase or percent decrease, you always want to find the amount of change first. That is done by taking the final amount and subtracting the initial amount. That's the quantity that's going to go on the top. If it's an amount of increase, then this quantity will be positive, which is a positive percent change, which means increase. If the price went down, then the difference between the final and the initial will be negative, and a negative percent change means a percent decrease. You always divide it, this is very important, you always divide it by the original amount, and then that'll give us the decimal, and we can just change it to a percentage by sliding the decimal spot 2 places to the right. Okay. For example, a municipal government promises voters that there will be a 15% cut in spending for the next fiscal year. The city's budget was $72.5 million, and it is projected to be $64.3 million for this year. Is the government keeping its promise? Let's explain. So they're claiming that there's going to be a 50% decrease in spending. It is projected to be, so we think now the amount is going to be 64.3, and this is down from the 72.5 million from the past year. So let's go ahead and compute the percent change. It's final minus initial, all divided by the initial amount. When we set this up, the final amount, which is the current amount, that's the 64.3 million. This is subtracting off the starting amount, which was the past year, which is 72.5. And again, it always has to go over the original amount of 72.5 here. 64.3 minus the 72.5 would give us an amount of decrease of 8.2 million divided by the original 72.5 million, and we get a decimal change of negative 0.113. Sliding it 2 places to the right would give us a negative 11.3% change. So obviously it's 11.3%, that's the amount of change, and the fact that it's negative is what indicates that it's a decrease. So to make a long story short, no, they are not keeping their word. They promised a 15% cut in spending, and according to this projection, this would only create about an 11.3% decrease in spending. Let's take a look at, I believe this is our last example in this section. Actually, no, we got a couple more. That's maybe it. So here, they say that a department store advertising that certain merchandise was reduced by 25%. And then after that reduction, they will then give another 10% discount to the first 200 people that enter the store that day. And they're claiming that that 25% reduction, followed by an additional 10% reduction, will create a total of 35% reduction. Is this an honest assessment of the total savings that those particular shoppers could expect? Let's find out. So to kind of keep track of the amount that we're going to get off, let's assume that the item was originally priced at $50. And actually, I'm going to work it out live because I think that's a horrible assumption. Typically, if you're trying to assume something, again, and we're using percentages, let's assume that we're starting with $100 because again, percent is part of 100. So let's assume that we're starting with an item that's $100 to begin with. The first discount, they said, is going to be 25%. So if we take 25% of 100, that of course is going to be $25. So the first discount we receive is going to be that of $25 off. If I take my $100 and I take away the $25, that would bring our price down to $75. But then they say, oh, wait a minute, we're actually going to give you another 10% off. So let's now take 10% of 75. That should be 750. And if we take that amount away, 75 minus 750 should leave us with 6850. If the math in my head's correct. 6750, sorry. So 6750. And if we think about it, we had an original starting price of $100. After these two discounts, we end up with a final price of $67.50. The difference between 100 and 67.50, can calculate your percent change, that's going to be what? $32.50 out of 100, which would be a percent change of 32.5%. But they claimed we were actually going to get a 35% reduction in the price, and that's not true. Okay. So the real percent reduction was the 32.5%, not the full 35%. And the reason for that is whenever you do successive discounts like this, yeah, the first 25% came off of 100, but when we do that second discount, that 10% is coming off of a smaller amount. That's taking 10% off of 75 and not 10% off of the original 100, and that's why we're not getting the full 35% discount that they are quoting.